So, Dr. Starrett here today from LeTourneau University, and I want to talk to you about 3D printing. So a couple questions we'll look at today is how do 3D printers work, looking at their parts and so forth, and then also looking a little bit at how do I take an idea that I have that I might want to make and turn it into a 3D object in my hand. So we're talking, the type of 3D printers we're talking about here are FDM printers, fused deposition modeling type printers, and they kind of work like a robotic hot glue gun. So you've probably seen a hot glue gun, something like this. You put the plastic in this end, heats up the nozzle here, and then we extrude, we make plastic come out by pulling the trigger. And so a 3D printer is like a robot that has instructions to place the nozzle onto a bed and draw something on one layer of plastic, squeezing and squirting plastic in one nice thin layer, then raising it and printing another layer on top of that, another layer on top of that, and doing it in a robotic fashion, doing it very neatly and according to the instructions. And so the printer will have spools of plastic filament that will be used to make will end up being the plastic thing that we're making. The filament is pushed by what we call an extruder to the hot end to a heated nozzle. And so in this case, there are different types of plastics that we could use. Some maybe only need 180 degrees Celsius, whereas some may need as hot as maybe 260, I don't know, or 230, 245, something like that maybe. Often, of course, we won't print onto our hand, we print onto a flat bed, which is often usually heated as well, and it can have temperatures up to maybe 105 degrees. All right, so let's look at some 3D printers. So here we have one of my 3D printers working away. You can see the plastic tube where the filament is running down towards the hot end, and then underneath there you can see a little point, which is the nozzle where the plastic is coming out. You can see the heated bed here that the object is resting on. So both the print head here moves and the heated bed moves to get it in the correct position to squirt out a layer and make the object. Right now it is making a articulated sled. When it's complete, it will look something like one of these guys. They have jointed parts that are printed like this in layers on top of each other so that it prints all in one piece and it comes out as a flexible object. So we say 3D printer. The 3Ds are 3 dimensions. We'll be talking about printers that use Cartesian coordinates. So we'll have an X, a Y, and a Z. And so you can think about it as something like this. If you have a piece of paper, typically we draw X this way and Y going up and down on the paper. And so if you have a 3D printer and you want to know X, Y, and Z, think about taking this piece of paper and setting it on the heated bed. And so you have X in this direction, Y going back into the thing, and then Z is the vertical direction. Typically this point right here on the corner of the bed would be are 0 for x, y, and z, so it'll be the center or the origin of our coordinate axes. So to make a printer work, it needs to know where it is in the world, right? It needs to know as it's moving along, it needs sensors to tell it where is 0 for x, 0 for y, 0 for z. So we have these things called end-stop switches, or in this case, a sensor, but some sort of a switch or a sensor to tell it when it gets to 0. And so printers, when they're starting, they will do what we call homing. And so they will go, and the software will tell them to go and find where 0 is or where an end stop is. So we'll go and click an end stop so that it knows where it is in where the print head is with respect to the bed. And so in this, sometimes end stops can be at the minimum and sometimes it can be at the maximum. In this case, looking at x, remember x is this direction. And so as the head moves along this piece of extrusion, it goes from 0, x equals 0 would be over here. X equal maximum would be over here. And so this end stop switch, okay, when it comes over this head, clicks this switch, sends a message to the processor saying, click, I've hit my maximum, right? So this is x maximum, right? Looking at this one in the y direction, moves back and forth like this. The bed will move back and click this end stop switch here. So which will that be? Is that y at its minimum or at its maximum? Well, we need to think about where it is with respect to the hot end, right? So the hot end, the nozzle is down here. That is what touches the bed, and that's kind of where the whole coordinate system is based off of. And so when this bed is pushed all the way back over here, the nozzle will be at the front edge of the bed, so that means y equals 0. Okay, so this end stop is a minimum end stop. It's at the y equals 0 point, whereas this one was a maximum. Now for the z direction, on this printer, we don't have a switch. We have what's called an inductive sensor. And so as the motors turn these lead screws, the print head comes down and the nozzle gets closer and closer to the bed. And so when the nozzle touches the bed, hopefully it makes sense that would be z equals 0. And then when the nozzle touches the bed or gets very close, this sensor senses the bed and tells it, okay, I've sensed the bed, we are at z minimum, right? Because at the bed is minimum. The higher it goes up, z gets larger and larger. And so after it's home then, found x, where x is maximum, but it knows how wide the bed is in terms of the software. It knows how wide the bed is, so it knows where x0 is. Find y0, find z0. Of course, 3D printers are made up of lots of pieces and parts. We have bolts and nuts and spacers. Just some conventions for when you're building them. If we have an M3 by 16 type of a bolt, would be what we have shown here. Typically, the first number is the millimeter diameter of the bolt, the threaded part of the bolt, and then the second number is the length of the threaded portion of the bolt. We have inserts that we can heat up and set into the plastic to make strong threads in plastic. We have different regular type of a nut that has plastic in it, so it makes it a locking nut, or we call it a nylock. We have these type of nuts that we call T-nuts that can go, excuse me, that can go into an extrusion and hold things onto an extrusion in that manner when a bolt is threaded into it. Okay, so another very important part of a 3D printer is what we call the hot end. And so you see picture here, hot end has various components. These are two different machines here. So here is kind of a basic drawing of the hot end. The nozzle down here is what needs to be heated the most because that's where the plastic is going to be coming out and going onto the bed. And so we'll have the nozzle here. We have some sort of, we call it the heater cartridge that goes into this. We call this a heated block or heater block. Okay, so this is, I believe, aluminum. And so the cartridge heats this whole aluminum block and in turn heats the nozzle, which heats the filament. So the filament will come down through the center of all this and get squirted out the nozzle. Okay, it will be under pressure, pushed by the extruder to come out. And so we have this part where we want it to be heated. We have the, in this little hole, we would tend to have, where we need some sort of sensor to measure. And so you can kind of see here, we have the red wires are going to the heater cartridge, right? And then we have these other wires that are going to a thermistor, which is a sensor, a temperature sensor to know how hot it is so that it can be controlled. You can kind of see the same thing here. This is the heater cartridge here coming into this heater block. You can see the sensor wires kind of coming around going into the hole on the other side. So we want this part to be hot. We have this part we call the heat break, which we want to start having things be cool up here because we don't want the plastic to melt all the way up through this whole channel or we have a problem. Right, we just want plastic to be melting at the very end and get squirted out. And so we call this the heat break. It's threaded in typically to the heated block. And then we have the heat sink. So this thing has a whole bunch of surface area trying to cool off, okay, the plastic and keep it cool as we go up. And this is a quick connect part that will hold the tube that the plastic comes through. So you can see here, this quick connect here is what is drawn here. Inside here, you can't see the heat sink, but that is what the fan is blowing on. So we have the heat sink that has all the surface area to try to cool off the hot end, but then we also have pretty much every 3D printer has a fan that blows on the heat sink to also try to keep it cool. So it's important. You can kind of see the heat sink on this one. It's a little bit different shape. But it's important to have that fan working so that the plastic doesn't melt too far up. And so we need this part to stay cool. One thing to note, some 3D printers have one nozzle. We would call it single extrusion. Some have what we call dual extrusion. This one here, notice there are two nozzles. And so we could have two different kinds or two different colors of plastic going through here, and it could print two different colors at once, or alternating or on the same part without having to switch out the filament. And so each one will have its nozzle and its heater block. It will have its own heating cartridge and its own sensor. This one shares a heatsink between the two of them and shares a fan. Okay, so the hot end, very important. It's what melts the plastic and gets it onto the plate. It's what is moved around to make the part. The extruder. So what does an extruder do? It is what actually pushes the plastic into the nozzle. And so there are two types of extruders. One is called a Bowden, which has a tube. Okay, so the extruder isn't necessarily close to the hot end. This one you can see is mounted on the side of the printer, and then the tube goes over to the hot end as it moves around. That's a Bowden type with a tube. Direct drive has the extruder mounted right on top of the hot end so that there is no tube, and it pushes the filament directly in. And so having a direct drive is better if you have flexible filaments and things like that that might get stuck in the Bowden tube as you were printing and so forth. But having a direct drive does make that print head a lot heavier, slower moving, and things like that. All right, so looking at the extruder, we see the filament coming in here into this movable part here, and the filament goes in between this drive gear that has teeth on it, and then this is a pulley that just rotates. And this drive gear is connected to a motor underneath, right? See, here's a drive gear connected to the shaft of the motor, and so as this turns, it grips the plastic and pushes it this way, pushes it through the quick connect into the tube that's going to go on down to the hot end. And so when you're trying to, say you want to put filament in, you can push on this part, compress the spring, releases the tension in between these two pieces, so you can feed the filament in into the tube. All right. You can see the parts shown out here, but basically we have a spring-loaded lever that makes this pulley push against the tooth gear to keep pressure on the plastic as it's gripped and pushed through the filament, or through into the filament tube, or the Bowden tube, we call it. All right, mentioned this before, but another important part is the heated bed. This is a picture of a backside of a heated bed. It has all these, say, wires, resistive elements. You see all these lines inside the aluminum, and so they all heat up and heat the bed. It has, if it's put in, this one is one before it's put in, but it has another thermistor, temperature sensor that's in the center of the bed that is measuring how hot it is. And these are the connection places where you would solder to put the power to heat the bed, and this is also connected to the thermistor so you can take the measurements out. And so when it's flipped over, you print on this side. This one has a coating on it, but the heated bed then helps keep the plastic warm while the new plastic comes on, so it helps to minimize warping and probably help it stick better at the beginning as well. And so this is probably the most, or is the most power intensive part of the 3D printer. It takes a lot of electricity to heat this much aluminum and keep it hot, maybe at 100 degrees Celsius, or maybe for PLA at 60 to 70 degrees Celsius. This is why you need a significant power supply for your 3D printer. We've had models that operate at 12 volts and take almost 29 amps for the heated bed. Other models that go up to, so basically we have a constant power. So if we have a model that goes up to 24 volts, remember power is voltage times current, and so if we're taking, or we're using a higher voltage than the current, double the voltage, then the current can be half as much. And so that's a good reason to have a higher voltage on your power supply, so it doesn't have to provide quite as much current, and so then the wires don't have to be as thick and so forth for your heated bed. So we mentioned the temperature sensors, thermistors before. So they look like a tiny glass bulb that has a heating or a measurement element inside of it. Basically, it is a variable resistance, and so it has a negative temperature coefficient. And so when the temperature is higher, the resistance goes down. But the 3D printer software is calibrated to these, and there are different types of these. But basically, we have a calibration so that we can know what is the temperature of the hot end or the heated bed. So each printer at least will have two. If you have two nozzles, two extruders, then you probably have 3 thermistors, one for each hot end, one for each nozzle basically, and then one for the heated bed. So these need to be in close contact. They have very thin wires and very light insulation, so you have to be careful that nothing pinches the insulation or that things don't get shorted, but they are good at measuring the temperature and can handle very hot temperatures. As I mentioned before, for this model printer that we showed, we have a sensor, an inductive sensor, that measures when Z gets to 0, when the nozzle gets close to the plate, or when the sensor gets close to the plate, and the sensor is mounted close to the level of the nozzle so that they are getting close to the bed at the same time. And so this one is an inductive sensor, has a variable inductance, and so the microprocessor board can sense a different voltage based on the different inductance. When this point gets close to something metal, it will change and tell the microprocessor that it has gotten close to the bed, and this is where Z equals 0. Many printers do not have automatic sensing like this, and then they would just have a switch that, like the X and Y end stops, that would tell it where 0 is. The benefit of having a sensor like this is it can move and measure at many different points on the bed. And so with a switch, it clicks one switch in one place, and so if the bed is not level, it may be good in one point where the switch is, but then it may be way above the bed or way crash into the bed in other places. So you have to be very careful of the manual bed leveling. With a sensor of this type, or there are other types of sensors, maybe touch sensors and different things, that can move along with the print head, then you can have automatic bed leveling, and so it senses where the bed is and can actually, if the bed is not very level with respect to the x-axis, it can actually move up and down as it's printing to adjust for the unlevel bed. One very nice feature with 3D printers is what is called an eccentric spacer. Eccentric basically means off center, and so you notice that the hole in this kind of nut looking thing, but it has no threads, it's smooth inside, but it has an off center hole. So the hole is closer to this side of the nut than it is to that side of the nut. And it wouldn't seem like it's a big difference, but when you're trying to get wheels to tighten to go into a extrusion channel, it can make a lot of difference. And so this part goes into the hole, in this, say, this blue part, and when you turn this nut, it pushes this bolt either farther away from the extrusion or closer to the extrusion so that the wheel gets tighter or looser. And so if you have a machine, it helps for long-term usage of the machine. If the wheels wear a little bit, you can tighten the spacer to make sure that it moves smoothly on the axis, no wobbling, no bumping along there. And so the eccentric spacers are a very nice feature for 3D printing. Something that is often needed when you're building a 3D printer is to do crimps. So crimps are just tiny metal pieces that often come on a strip like this that are clamped onto the ends of a wire so that they can be put into a housing such as this and then easily plugged and unplugged things. So instead of soldering, we can have housings and headers that we can plug things into and unplug them then. But the key to that is getting these little crimps clamped onto the end of the wire, and so we have special crimping tools that bend these little flaps, one around the wire, or one set around the wire and one set around the insulation, to hold the wire into the they're called JST crimps, but there are different kinds as well, holding it into its place. That has a little flap that kind of pops out so that it can't back out in these holes, and they are clamped into there. We talked a little bit about power supply, but it is basically a power converter or a voltage converter, right? It takes AC and converts it to DC. So AC is alternating current, sine waves. Typical house is here in the US is 110, other parts of the world is 220. But it takes that AC signal, alternating current signal, and then in this case gives a 24 DC volts out, all right? And so many of them have a switch on the side that you can switch from if you're using 110 or 220 in terms of the input to the power supply. And then they have a specified voltage out. And so in this model, this is a model that we built, and so we have it taken apart, but we have the switch, the power switch here that the AC plugs into, and it's switched on and off, and then that AC comes into the power supply here, and then these, I don't have anything connected in this picture to the outputs, but then the DC, these probably are negative ports, and these are the positive ports that we can then feed the 3D printer DC power with. Electronics boards, this is an MKS Generation L version 1 type board that we use on one of our printers. We have, many of them are Arduino based, and so you can use Arduino IDE to code software. There is open source software called Marlin based software, and probably others that we've been using on ours to customize and do what we want to with the 3D printing and the ways that you interact with the 3D printer. And so this is one that has doesn't have everything connected. We can see we have along this side, we have these smaller chips put onto the board. Okay, so here's one where the chip has not been put in. And so these are what we call stepper motor drivers. And so the printer has motors to move the x-axis, the y-axis, the z-axis, and the extruders. And so each one, we have on ours an x, a y, a z, and then an extruder. And so these are the drivers that generate the signals to drive the stepper motors. We have places for end stops, x, y, z end stops. We could do minimum or maximum, so depends on which one you have. you put those in a different spot. We have power inputs here. We have heated bed, or I'm sorry, the heated bed output here. So we would connect in the wires to go to the heated bed here. And for the heaters for the hot ends, it has potential for doing 2, even though you don't have to use both. Has places for the thermistor. Excuse me. Has places for the thermistors to be connected, the LCD screen, and so forth. And so we also designed a small board to drive the LEDs that light up the 3D printer here as well. So it has ability to do different colors and so forth there. Another aspect of the 3D printer is the LCD screen and card reader. And so the LCD screen, we need you typically have some sort of screen, at least for printers that don't have to be connected to a computer to work, that are standalone. Have some sort of a screen that we can, and some sort of an input device. So this is a knob that rotates, but also has a clicker, so we can select things, so we can roll up and down on the screen and select certain things. We also tend to need some sort of a card reader. So this is an SD card, a larger card reader that is inserted into the side. So this device does 2 functions. It reads the SD cards and it shows the user interface for the screen. Okay, so now I want to give a little bit of a tour of some of my printers going on here. I lost my camera. So here's a printer that has actually 2 print heads. It has 2 extruders up here and one in the back that you can see. It has 2 Bowden tubes going down to 2 nozzles over there. It has an inductive sensor, so it does automatic bed leveling. It has the screen here. So the x-axis moves this way, and we have the z-axis is moving along on the bed. It is printing right now. So I've zoomed in here now so you can kind of see that it does have 2 nozzles down there. One of them is printing. You can see the power supply is mounted down under on this one, and the boards are also down inside the tray. We have a second printer here that I have 2 roll filament mounted on, but it is only a single. It has 1 extruder mounted here. This is one that a lot of the pictures are on. You can see the power supply and the electronics boards on the side here. And the end-stops are as you showed in the picture. I want to go ahead and show you what I would do to print. So I have my SD card here, and we'll talk about later how to get a model on there, but I have models on there in G-code, and so I would insert the card into the card reader, and then it says card inserted. We would click the button and just go down to print from SD. This is the Marlin code, and we would find what we want to print. And just click the button. It will start to heat up. Notice we have here on the screen, we have a picture of a nozzle and 2 measurements. One is the target measurement and one is the reading of the thermistor. And same thing here for the heated bed. This is the target, so it's telling the heated bed to heat to 70 degrees, and right now the temperature is 30 degrees Celsius. It says bed is heating. We have a bar along here that says how much of the printing has been completed. With 0, it is 0. We have time is taken, and we have the speed. So we can control the speed of the machine by just turning this dial. Again, this is specific to the Marlin code, so it'll print slower faster. But what's going to happen as it prints now is it's going to heat up the heated bed first at 70 degrees Celsius. Once that gets heated up, it's going to change the target on the nozzle to be 210 or something, whatever it is for. This is PLA plastic. Once the heated bed gets heated up, it will start heating up the nozzle. It will set the target for the nozzle to its target temperature and start heating up the nozzle. And as it's heating, it will also do its automatic bed level. So now we see it's reached its target on the bed, it overshot a little bit, and it started the heating of the nozzle. And you can see that it started to move. And so it's moving to different parts of the bed, and the sensor is sensing where the plate is, where the heated bed is, in all these different positions, and it's going to use that data so that it knows if it needs to raise or lower the bed as it's printing along, so that it can keep the nozzle at just the right height above the bed in whatever position it happens to be in. Once it's done its bed leveling, it will come over here and extrude extra plastic just to make sure that everything is flowing well. I like to have my needle nose pliers here be ready to capture that so it doesn't get stuck in the print as it's printing. But it's almost to its target on the nozzle, and once it gets to the right heat, it will start printing. I typically have it do a skirt around the outside just to make sure everything's flowing right and the bed is level. That's what it's doing now, and now it will start printing the actual item. All right, so there it goes. It keeps track of the time, and so you can kind of, and the progress, you can kind of judge what's going on there. Right, let's move on to the next printer around the corner here. This one I wanted to show you is a direct drive. So these other two that we saw have the tubes, they have the Bowden tubes, but this one has the extruder motor mounted right on top of the carriage for the x-axis. It also has these rods that it moves on, as opposed to wheels turning on extrusion. It has bearings on the rods. But this is the extruder here. This has a wheel to help you guide it. It doesn't have the lever arms. It has these screws that will pinch the pulley to the tooth gear inside of there. So you can see it's a little bit bigger, more bulky head here, but the filament, this is a fatter filament, but it pushes right down, and so the hot end and the nozzle, the extruder pushing and the nozzle are not that far apart, and so it's good for filament that is flexible and might not flow through a tube very well. Another thing I want to show you is my bucket of fail parts. So when you're doing 3D printing, there will be some waste, extra parts, there will be some failures, there will be the skirt and so forth. And so this, I have a 5-gallon bucket of pieces and parts, things that I've tried, things that didn't work, things that failed. And so it's just a part of it. So don't be surprised if you have a few failed parts. Maybe they can be recycled, I'm not quite sure yet. I'll show you another printer here. This is another one that has the dual extrusion. The one I want to point out is the tape on the heated bed. So we have this masking tape, painter's tape we call it, but most of my printers have these PEI sheets put on there to help things stick to the bed, but often in 3D printing it's very difficult to get that first layer to stick well, right? If you have just a bare aluminum bed, one thing that is quite helpful and helps things stick is to put some tape on the bed, maybe cover the whole thing, or at least cover where it's going to print, where the part might be. And that helps it to stick, and it helps you to be able to get things off. Another thing that is sometimes helpful too is to use some glue stick. And so even on tape, or if you have a glass or aluminum bed, people like to use glue stick. If you're having trouble getting things to stick, just put a little thin film on there, usually put some on there and maybe make it a little bit wet and spread it around so there's just a nice thin film on there to get the first layer to stick. So in 3D printing, one of the hardest things is to get that first layer to stick, but then one of the next hardest things is to get the thing off once it is stuck. So you print it, get it on there, and often very hard to get off. And so we have something like this sometimes comes with a 3D printer, and you can get it. I tend to use it and say we had this part that we printed. I would try to get it at the corner and kind of scrape at it and pull it up to get it to start coming up. I sometimes just use a knife, same thing, put it under the corner, and just try to get a little bit of it peeling up, get some leverage there, and pull it up so that you get your part off of the printer once it finally does get stuck, then you have to figure out how to get it off. Have a few more tools and hints here. One thing, the plastics tend to absorb moisture, and so if you're not using a spool at the moment, I tend to put it in a bag, put some of the silica in there to help it absorb the moisture so that the PLA works longer and it lasts longer. If it gets too much moisture, it tends to break. I've had it sometimes if it's been there too long, just when it's sitting on the printer, it will just break. And then you have to rethread it and all that kind of stuff. Soldering iron, when you're building 3D printers and doing modifications, the soldering iron is a very good tool to have. Zip ties are always very useful. You never know when you might need them. Little nippers like this are very nice for trimming the filament, if you're building for using wires and so forth. Screwdrivers, Allen wrenches, all very commonly used as tools. I have here also just a paper clip, and lots of printers come nowadays with a very fine needle because maybe the main problem for 3D printer, or one common problem, is getting things to stick and unstick. Another very common problem is the nozzle getting plugged up. And so let's look at this one. It's done printing its slug. But let's see if you're printing along and it stops printing. So here's the slug. It's kind of stiff at first, but then you just kind of bend it, and it's a slug. So you're printing along, and it just stuff stops coming out of the nozzle. So you check the extruder, everything is working. You decide you have a plug nozzle. So what are you going to do? So I would tend to make sure you have the hot end heated up, and then you can take the filament out. This is a quick disconnect. You push down on. So this is a quick disconnect. You're supposed to be able to push down on the black parts, and it lets go of the white tube, but I can't quite get this one to work. So you want to have your nozzle heated up so that when you pull this out, the plastic will come out the top. But if you can't get your quick disconnect to disconnect, you use your trusty tool of some sort to loosen it out of the threads. And so we're pretending like it's plugged in here, although this one is not plugged. But then you can pull the tube and the filament out. You can push it by hand, so you press the lever and push the filament through, and it pushes through there easily, so you can see that part isn't blocked. And the extruder, we could test the extruder and push it through, and it will be working. So we need to figure out what's going on somewhere in between here and the end of the nozzle is where the problem is. And so this is where you can push something through the top, find the hole, find the channel that goes through, and you can see the filament pushing out the bottom maybe. there's such thing as cleaning filament that you can put in, or just take a piece of this filament, or straighten it out a little bit, maybe trim the end so it's nice and neat, not a big lump on there. Put it to a point. Sometimes with PLA, I put a little oil on it so that it flows easier. It's kind of like oil in a frying pan. Then you can push it through, so you can see the plastic coming through. As I push it manually, it comes out the nozzle. The nozzle is not blocked. And so, if you have problems, though, you could put the little fine needle I mentioned. You can poke up through the nozzle to try to get the plug out. Push cleaning filament through if you have it. Just other pieces of filament, like I'm doing, to test it and clean it out. Make sure it's flowing. And then I'm going to release the pressure here and push the hot end, or push the tube down in like it needs to go, releasing the pressure so that the plastic can flow back this way if it needs to. And then I need to thread this back in there, which is kind of, actually I'm going to pull it back out and see what's wrong with my quick disconnect here. There. So that's what it's supposed to do, is disconnect. I'm going to put that back in. This is the disconnect. It's got threaded. Make sure you get all the plastic pieces out of there. Thread that back in. You pull the plastic back a little bit, releasing the pressure, pull the plastic back a little bit. And so there's a little bit of extra material. It's gotten cut into the material. That's probably why it wouldn't release. Sometimes it needs to go in, the tube needs to go in quite a ways so that it gets to the parts of the hot end and there is no gap, no place for the plastic to expand, filament to expand as it's going through and cause a leak or cause a blockage. All right, so I pushed it back in, and now I can push the plastic through like I'm being the manual extruder. And I see plastic flowing out the end freely and easily, judging how it pushes through. So my nozzle is unplugged, never was plugged, but the simulated plug nozzle is fixed, and we can do some testing. Usually I like to go ahead and test. I push it through easily, but we can also do a test of the nozzle itself and just have it tell the printer, make sure by the motor pushing through this. So I told it to extrude some plastic, and it did it just fine. And so one thing to note, a lot of the software has a protective protection to the extruder and to the motor. If the nozzle is not hot, when you tell the extruder to go, it will not go. So I thought my printer was broken at times because before I learned this, because I was telling the extruder to go and nothing was happening. I thought the motor was broken, but there is a safety in there. So you need to have the nozzle heated up and then try to test the extruder, and it should turn and push the filament out. Okay, so that was our tour of 3D printers and 3D printing. Let's go on to now, how do I get that SD card with stuff on it? So if I have an idea, I want to create the newest, greatest invention. How do I get that idea out of my head into an object, turn it into an object in my hand? So we'll usually need to use at least 2 pieces of software to do that. We'll need a computer with some sort of CAD software, computer-aided drawing software, to make the 3D object, the 3D model. There are websites that may be available, or you might be able to find things on the internet, objects that other people have made that they are just putting out there for free. One place I found is called Thingiverse. It has lots of models that you can, if you don't have CAD software to draw, or if you just want to make something, they have lots of things there. So what we need then is some sort of a program that you make yourself, or you made the model, 3D model yourself, or somebody else made it, And typically what we want is a .stl file. STL is standard tessellation language. It's kind of a standard format for 3D models and software, 3D software. And so get an STL file somewhere. Okay, like this, the things that I've been printing, I have an STL version of that. So something.stl. All right, so first software you need is CAD program, or you need something to get the model made, get it drawn, get all the dimensions right, get the parts added to it, right? So once you've got your model made, you save it as an STL file, and then you go to what is called the slicer program. So the slicer program cuts your model into slices, right? It slices it up, so it makes the different layers. So 3D printers, FDM 3D printers need the model cut into layers, and it prints it one layer at a time, right? And so the slicer is really a smart program, has lots of features and lots of things in it that will slice it to your specifications. So if you want very, very small layers, so a big layer is a 0.3 millimeter layer for the printers that we've been using here. If you want a very fine layer, you make 0.1 millimeter layer. You tell it how thick the layers are. You can tell it all kinds of different things. You tell it the size of your heated bed. You can tell it speeds. You can set fan speeds. They're just typically many, many different options that you can set in the slicer program. So the slicer program reads the STL file, works on slicing that model up to be what your 3D printer needs, so it knows the parameters of your 3D printer in size and so forth, and you tell it what kind of filament you're going to use, and then it also has a 3D model, and it puts all that together and generates what we call a G code. All right, so some file, something.g code would be the name of the file, and that's what you would put on your SD card. So some printers have the large SD cards like I showed you, and some have the micro SD cards, but you put it on a card, and then you put that in the printer, and the printer can read the G codes. And the G code is just a text file, and it just says make X, Y, Z go here at this speed, make the extruder go this speed, make the elements heat to this. It tells the printer every little thing to do, every little place to be, every heating thing to do, the speed of the fan, all the details are told to it. Many, many details are told to it by the slicer program inside the G code. And you can go into the G code, it's a text file, you can go into it and modify it if you need to. For example, one thing I've done, and you can read the G code and write G code yourself also if you want to, but one thing I've done is if you have a object that you want to print in 2 colors, but you only have one extruder, one nozzle, you need to switch colors in between. And so you can put a pause, and so the printer prints and prints. And you could probably do this in the slicer, but I haven't figured it out. But I just went into the text and added a pause statement in there, and then it waits for me to change the filament, and then I change the filament and it continues printing. And so it is a text file that you can read and modify if you so desire. All right, so let's look at a little bit about how to take a model and get it ready for printing. And so there are many different CAD softwares out there. It kind of depends on what you have, what you want to use. This is I think it's kind of made for children possibly, but it's not really full engineering strength, but it is one that I can show you the demonstration. So you would have some sort of a model. You can typically look at it in 3 directions, or 3D. You should be able to see it in 3D. You can add to it, draw things, however, whatever you want to have. And so I made this coin holder with our LETU letters on it. And so you have some sort of model that you've made in your CAD software. And so the CAD software is very good at drawing things, making shapes, doing things like that, but it doesn't do the slicing. So you will need to then take that 3D model and export it as, like I said, an STL file. So hopefully whatever software you have for CAD drawing can generate a .stl file. So I would generate a .stl file. I don't know if we need to wait for this. Let's just say let's call it test. So I've generated an STL file with my CAD software. There it is. And so I want to open the Slicer program. And so this one is called Slicer Prusa Edition. And this is one I've done before. I'll delete it. Okay. And so I want to add my model. So I go find it. So the Slicer program reads the STL file, reads the object and puts it in here. Okay, you can see it in the different dimensions. It has many, many settings, as I said. So this one, you can set the type of plastic filament you're going to use. So maybe PLA plus. It has different printer settings, so you can put in which printer you want to use. These are things that I have made, okay, in the starter settings. And so you notice that the size of the bed changed and the location of the XYZ coordinate plane change, or coordinate origin changed. And so you can place it on the heated bed where you want it to print. You have print settings in terms of your layer heights, all these different kinds of things. You have filament settings. You have printer settings. You tell the size of your bed and so forth. And so once you get it how you want it, then you need to export G-code. And so basically you just click this, but once you got your settings right, you export the G-code, click that, it will make a G-code for you. And then once it's done that, it will show up there. You can take that file, copy it onto your SD card, and plug it into your printer, and it prints away. It will do the heating, preheating, and all that is built into the G-code. Actually, you can see that in the printer settings. You have the custom G-code, and you tell it what to do before, what to do after, do between layers. And so there's many, many settings that you can set in here. I guess one thing that's a common thing that you might want to look at is in terms of the filament, the temperatures of the layers, the diameter of the filament, and then the, where is that, print setting? Here we go. Infill. And so typically things are printed not solid plastic parts, but things that are hollow or have some support. So you can set the infill and set what percentage you want of it to be full plastic on the inside. And so it will generate generate the layers that way. Actually, let's look at this one. So since this one has been sliced and exported, you can actually see the preview and you can look at the layers. So you can see, let's see here. So you can see what it looks like on the inside, the honeycomb kind of pattern, which you can change of the 3D. You can look at it this way, or you can look at it in terms of the layers, and you can see the bottom layer. It has words in there upside down, but you see the honeycomb is the infill that's filling in the hollow, so it gives it some support, but it doesn't use up so much plastic. And so you can see layer by layer how it makes the thing. It shows you how it draws the filament on there. So very smart programs that do a lot of calculations and generate the G-code. And then I guess we can just look at the G-code real quick. But so the G-code then is just, G-code is just text that you can read. It tells it what X, Y, and Z positions, what extruder positions to go to. It tells the speeds and so forth, and you can learn how to write this if you want to, but just very long file, layer by layer, telling it what to draw piece by piece. Okay. So that comes to the end of my presentation. We all are made to love to create things, I think, so go out, create something, print it, and just have fun.